The various theories of evolution declare that the Earth and the universe are billions of years old. Evolutionists say that we are just the result of a cosmic accident, that we are just thinking animals without specific design or purpose. In school, most of us were taught that life began by random chance chemical reactions. Yet when we see the beauty of the Earth, we see the complexity of the living organisms that occupy it. Can we really believe that this is all just an accident? Throughout the world, we are presented with the evidence that calls into question evolutionary beliefs and the assumption of an old age for the Earth and the universe. Over the course of this program, we will present to you evidence that will shake the foundations of the evolutionary worldview. Evolutionists say that the Earth is, in fact, millions and billions of years old. First of all, you have to understand that they have no proof for this whatsoever. They simply claim it. And you have to realize that evolutionists live and die by 8 words. Those 8 words are so important that you should memorize them. So I want you to try memorizing these words. Please repeat after me. Give me enough time. Give me enough time. And anything can happen. And anything can happen. Those are the 8 words by which evolutionists live and die. We might call it the evolutionary mantra. You see, in spite of anything and everything you can show an evolutionist that evolution is not true, they will simply respond by saying, give me enough time and anything can happen. So the question must be, has there ever been enough time? Now, I was once asked to write an article for a publication. When you're asked to write articles for publications, sometimes they give you the title of the article and say, we want you to write it. Sometimes they say, pick your own title and write the article. And I was given the title. The title was to be, how do you date a rock? And my first response was, first you have to ask her. Well, some of you got it anyway. So, I mean, let's think about this. Is there anything about a rock that will tell you how old it is? Is there anything about the size, feel, shape, smell, taste, weight, mass, specific gravity, density, chemical composition? Is there anything about a rock that will tell you how old it is? And of course the answer is no. There's absolutely nothing about a rock that will tell you how old it is. As a matter of fact, I can go outside right now, pick up any rock I choose to. I can claim any age I want to for it. You may disagree with me, but you cannot prove me scientifically incorrect. You understand, I can go outside right now, pick any rock I want to, claim any age I want to for it. You may disagree with me, but you cannot scientifically prove that I'm wrong. I mean, think with me. When you go outside and pick up rocks, do they come with little white strings attached, little white tags saying, I'm 10 million years old, and signed by a scientist who was there at the time? Excuse me? No. So let's think about this. Is there any way in which you can date a rock? The answer is no. There's no way that you can date a rock. And so what we want to talk about is, are the Earth and the universe really billions of years old, or are they, in fact, young? Now people will say, well, you know, the Earth is old. It all came from a Big Bang. Supposedly this Big Bang occurred some perhaps 20 billion supposed years ago. But is the Earth and the universe really 20 billion years old, or can you really trust the Bible to tell you the truth that it was created just 6,000 years ago? Now, you say a young Earth, young universe, and people will say, but wait, doesn't it have to be old? Because, and they will say things like, doesn't it take millions of years for rocks to form or for diamonds to form? What about stalactites and stalactites to form? What about polar ice caps to form? What about thousands of feet of rock layers to form? I mean, doesn't that take millions and billions of years? Or what about deep canyons to be cut into rock layers? What about dinosaur fossils to form? Doesn't that take millions of years? Or perhaps they say coal. Doesn't it take millions of years for coal to form? Or wood to fossilize? And the big one always is, doesn't it take millions and billions of years for light to reach us from distant stars? I mean, that's the big one that everybody asks. But I say it all has to be young. I say it all has to be young because. Now, I always like to start with something for the ladies. Now, ladies, this is a piece of opal mineral rock. This is dug by hand from Australia, and that's a nice stone, right? Oh, come on, ladies, that's a nice rock, right? Now, that's a piece of natural opal from Australia. This is a piece of man-made opal from Australia. Under an electron scanning microscope, you can't tell the difference. But this artificial man-made opal was grown in that jar right there. Have I got your attention? You see, this is a natural piece of opal stone mined in Australia by hand. We want to take a look at, does it take millions of years for gemstones like opals and diamonds to form? And what about gold to form? Well, this is a natural piece of opal. This is a man-made piece of opal. It was grown in this jar right here. You can actually see it growing right there in that lens. And it only took 3 months. Have I got your attention? You put the right chemicals in a jar, stick it up on a shelf, and it can grow an opal in 3 months. Now, I want to assure everybody here, if you have opal jewelry, it's real. This gentleman is a Christian, a creation-believing scientist. He only does this as a laboratory experiment, but he's found out how to do it. But he doesn't sell them. He doesn't put them on the market. He doesn't flood the market with these things. But it only takes 3 months to get an opal. Or how about that rock right there? Come on, ladies, that's a nice rock. Oh, come on, that's the Hope Diamond in the Smithsonian. That's a nice rock, right? Yeah. But evolution said it takes millions of years to form diamonds. Well, first of all, though, you really know that that's not true, because if you think about it, you know that we've been able to make industrial-grade diamonds for many, many years. It takes a few months. We simply subject carbon to heat, pressure, and so forth. But these are crude diamonds in the sense that they're not gem quality diamonds. They are diamonds, but they're only used for abrasives and grinding and so forth. But are you aware that in 2003, we found out how to make pure, super hard diamonds in only a matter of minutes? Now, it takes high pressure and high temperatures, but it only takes a matter of minutes to get gem quality, pure diamonds. Are you impressed? Well, think with me for a moment. You know how scientists are. If we learn how to do something, well, then the next question for a scientist is, how do you do it faster or cheaper or both, right? So the very next year, we found out how to do it at much lower temperatures, much lower pressures, and it only takes 12 hours. Is this interesting? Oh. Well, but you know how it is with scientists. If you learn how to do something, the next question is, how do you do it cheaper or faster or both, right? Well, in 2006, we found out how to make flawless, pure diamonds, up to 10 carats. It only takes 1 day. Today in the United States, you can go into a jewelry store, you can buy a diamond, you can either pay for a natural diamond or you can get a man-made diamond. They're of equal quality. And the man-made diamond is cheaper. And you now have a choice. And let's think about this. We now know that kimberlites, which are what you find diamonds in, actually come up from deep inside the earth at about 9 miles an hour. It only takes about 12 to 30 hours for this material to come to the surface of the earth. We found that out in 2000. And this is another report, 1999, showing that, again, it only takes about 2 to 8 hours for these materials to come to the surface of the earth. So I guess it really doesn't take millions of years to get a diamond. Is that correct? Have I got your attention? Well, what about gold? I mean, doesn't it take a long time for gold to form in nature? Well, actually, no. The massive Lihur gold deposits in Papua New Guinea could have formed in, quote, as short as 5 hours, unquote, claims geologist Greg Hall. That's January of 2007. Here, in a report that actually goes back to 1985, water sampled from over half a mile down by these geochemists contained, quote, 1,000 times the highest concentration of gold ever recorded in the surface waters of hydrothermal systems, unquote. But this was found at a geothermal power plant in New Zealand back in 1985. Today, we now think that there's approximately 53 pounds of gold being deposited in this gold mine while it's being mined. Well, 53 pounds of gold is no shabby, right? And what about stalactites, stalagmites? I mean, doesn't that take millions and millions of years to form? I mean, think with me for a moment. When you go to places, the caves, and limestone caves that have stalactites, stalagmites, don't they say to you, oh, it takes 10, 20 million years to get a cave like this? Is that right? And the other thing they say is, don't touch that. Right? Come on, they say, don't touch that. It'll take 1,000 years to grow back, right? Well, I'd like to see if it really does take 10, 20 million years to get a limestone cave like this. I'd like to see if you touch it, does it really take 1,000 years to grow back? Now, we're looking at, do stalactites and stalagmites form slowly or fast? Now, this is a photograph of some Mayan pottery made in the Americas. We know it was made about 700 AD. But in this photograph, you'll notice right here, this is a stalagmite coming up from on top of the pottery. Is that correct? So let's think. Here's this stalagmite on top of the pottery, so that means it formed in less than 1,300 years. Is that right? So if it only takes 1,300 years for this stalagmite to form, I really don't think it takes 10, 20 million years, do you? Not really. There you go. Or how about this? Now this comes from Australia. This is a man-made tunnel. We might call it a man-made cave. It was dug 160 feet deep into a basaltic or a volcanic hill in Australia in 1857. But here you see this beautiful flowstone. Here you see these stalactites coming from the ceiling. Now let's think. This photograph was taken in 1997, so it only took 140 years for these formations to form. So I don't really think it takes 10, 20 million years to get a limestone cave. How about you? Oh, come on, can y'all say not a chance? A little louder. Not a chance. Very good. And evolutionists will tell you, well, the polar ice caps contain perhaps a quarter million years of accumulated ice and snow and so forth. As a matter of fact, they will tell you that you can see the little lines in the polar ice caps and say, you can see 200, 220,000 lines there and so forth. First of all, that's not true. It's actually a lie. I want you to think with me for just a moment. How many of you have opened up a refrigerator freezer door and you've seen two ice cubes flowing together in the middle of the freezer? Is that right? Oh. Now, it is true that you can see these little lines near the surface at the top and even down into the middle, but once you get down in the middle, the pressure of the ice is so great that those lines simply become invisible, and after that it's just, subjective judgment and so forth. And they'll tell you that these little lines in the polar ice caps, those are just like annual rings in a tree. You cut down a tree, you count the rings, and they say, oh, well, you can see 200, 220,000 lines. They're just like tree rings and so forth. So this tells us that the polar ice caps are 220,000, years old. But I don't think so. I mean, when I was an evolutionist, I used to accept that kind of thing, but I don't believe it anymore. Let me show you why. Now this is a Boeing B-17 medium-range bomber from World War II. This is a Lockheed P-38 fighter from World War II. In 1942, two bombers escorted by 6 fighter planes left the United States to go to England as a part of the war effort in World War II. Now these planes cannot fly directly across the Atlantic. They don't have nearly enough fuel. And so what they must do is they have to fly first to Bangor, Maine. From Bangor, Maine, they fly to Newfoundland. From Newfoundland, they fly to Greenland. From Greenland on to Iceland and on down to England. Now, these 8 planes took off from the U.S. in 1942. They got to Greenland, and they fueled up on the west coast of Greenland. They started across the polar ice cap of Greenland, ran right smack into a snowstorm. This was a complete whiteout. They couldn't go forward. They tried to turn around, find the base they came from, couldn't find the base they came from. They decided they were going to have to crash land on top of the polar ice cap. Now the first plane went in with its wheels down, flipped over. Everybody said that's a bad idea. So the other 7 planes came in with the wheels up and just belly landed. Now after the storm was over, the crews were rescued, but the planes were left there because it was much cheaper, much faster to just build new planes back in 1942. But in 1988, some enterprising American men remembered that those planes were up there, and there's a lot of money in antique aircraft, especially military, and so they decided to go up and get these planes, rehabilitate them and so forth, make some money. And so they took brooms and shovels up there to find these planes. Now you have to understand, these planes are not heavy enough to sink into the ice. Wherever they landed is where they stayed, okay? So they crash landed in 1942. Planes stay exactly where they landed. Well, it's only been 46 years. Anybody want to guess, tell me how many inches, or if you prefer feet, of ice and snow they found on top? Anybody? I mean, it's only been 46 years. How much ice and snow do you think they found? 20 feet. Thank you. I have an opening bid of 20. Do I have another bid? 10. Okay, we have a bid of 10 feet, 20 feet. I'll take one more bid. 50 feet. Oh, my goodness. Well, I have to stop the bidding because all of you are just a little low. You see, what we actually found was 250. In 46 years, 250 feet of ice and snow had formed on top of the plains. This is a picture of Glacier Girl as she looked when found 250 feet below the surface. They had to come back. They couldn't find the planes. They took back the brooms and shovels, came back with sonar and radar that would penetrate the ice, finally found the planes 250 to 270 feet below the surface. They actually had to come back with heavy equipment, bore these big holes all the way down 250 feet. They've actually disassembled her, brought her back up in pieces, reassembled her. She's one of the few flying P-38s in the world today. So let's think. It only took 46 years for 250 feet of ice and snow to pile up on top. That's 5.4 foot per year. Is that correct? I don't think those little lines in the polar ice caps are annual rains. I don't think those are years. I think those little lines are individual storms. That would be much more reasonable, wouldn't it? Oh. Now this is a picture of the Upper Grand Canyon of Arizona. And here you see hundreds and hundreds of layers of rock, right? I mean, it's a beautiful area. Now, evolutionists would tell you that these layers could span millions and millions, even hundreds of millions of years, but I would like you to think about it something for just a second. First of all those layers you see here are sedimentary rock. Now, what is sedimentary rock? Well, it comes from the word sediment, correct? So if I had a glass of water here and I threw dirt and sand into the water, whatever settles to the bottom would be called sediment, correct? So sedimentary rock is water deposited rock. You remember from school there's only three kinds of rock: igneous, metamorphic, and sedimentary. All these layers of rock you see here are sedimentary rock. What you really see here are just layers of dried out mud. That's everything you see here. These are just layers of dried out mud. And I say it takes just 1 year to cut that canyon. That these are just the wet mud layers laid down by the flood of Noah, that this whole canyon was cut in just 1 year. Now, of course, you could argue with that, but let's just take a look at it. This is a picture of the south wall of the Grand Canyon taken at sunrise from several miles away. This is the Colorado River. Now, when you see these layers, you see hundreds and hundreds of layers here, is that correct? But they're all layers of dried out mud. Now, if you were to believe that all these layers came from individual floods, you would have to believe that about 1,000 floods of roughly equal depth occurred one after the other exactly the same way, covering hundreds of thousands of square miles. Now, does that even seem acceptable? That's a little tough, right? And I'd like you to think about something with me for a minute. A good scientist always asks two questions. The first question is, what's there? Meaning, when I make a scientific observation, I have to adequately and accurately describe what is present, what is there. But the second and more important question in science is, what is not there? You often learn more by asking the second question than the first. Now, let's ask ourselves the two most important questions in science concerning the Grand Canyon here. What is there? Well, we have hundreds and hundreds of layers of dried out mud. Now, think with me for a second. If each of those layers was laid down by an individual flood, then there would have to be some time for each layer to be exposed before the next layer was deposited on top, correct? Right? If it's one at a time, one layer's, then there's a time of exposure, then a second layer, time of exposure, then a third layer, right? Now, if that were true, if each of these layers here seem flat, although they're not flat, they actually undulate and they twist and turn and meet each other at a 90-degree angle. And if you go to the north side of the canyon and you go up the North Kaibab Trail, there's a place where you can actually see one kind of sedimentary rock completely surrounded by another kind, like a donut, but the donut is surrounded by the kind of dried out mud that's in the middle. Well, if each of these layers is supposed to represent different ages, that each one was laid down, there was a period of time of exposure between the next layer being laid on top, then please tell me, why are there no soil horizons between the rock layers? I mean, if the rock layers have been exposed, we would expect some weathering, we would expect some of the rock to turn into soil, is that correct? But there's no soil horizons between the layers. Why are there no V-shaped erosion marks in the layers? I mean, think with me for a minute. If you have a layer deposited, rain falls, starts to etch a V-shaped erosion mark into the layer, then the next layer comes in, is going to fill that in, it's going to preserve it, is that correct? But there are no V-shaped erosion marks in these layers. There are no animal holes, there are no root holes. That's all missing. So what does that tell you? It tells you that all of those layers of dried out mud occurred in one year by a big flood called the flood of Noah. And because there's no soil horizons, V-shaped erosion marks, animal holes, or root holes in the layers, it proves they were all deposited at one time. Now, there are evolutionists who rely heavily upon radiometric dating processes to determine the age of a rock. Now, understand, anytime I use a big word, I always wanted to define what it means. What does the word radiometric mean? Well, it means the use of radioactive materials to supposedly measure the amount of time since an event has occurred or a creature lived. You've all heard of carbon-14. Maybe you've heard of uranium, lead, potassium, argon, rubidium, strontium. There's all kinds of these, but carbon-14, potassium, argon, rubidium, strontium, uranium, lead, those are the ones that most people know of. Actually, there's over 80 of them. And they say that you can date a rock, millions, billions of years old using these radiometric dating processes. However, that's not true. First of all, none of them work. Not one of them works. Carbon-14 doesn't work. Even the man who invented it, Dr. Libby, admitted it didn't work. But none of them work. First of all, none of them work because they all start with 5 false assumptions, and carbon-14 has 7 false assumptions. Now, would you agree with me that if you have a dating technique based on 5 false assumptions or 7 false assumptions, then you're not going to be able to get a reliable date? Is that correct? I mean, that's right. You also have to remember that in the case of carbon-14, that the flood of Noah would drastically change the carbon cycle, so that really throws it off. And then would you agree with me on something? If these things actually worked, if they did, and you could use 2 different methods on the same rock, wouldn't you expect them to be approximately the same date, about the same age and so forth? Is that right? I mean, agreed? If you could use 2 different ones on the same rock, if they work, they should be about the same, right? Okay. How about if I was within 10%? Would that be satisfactory? I'm willing to negotiate. What do you want, 15%? 10s, okay, well, I got 10's enough, okay. Well, good. Well, here's the problem, you see, not only do these methods not work, there are major contradictions between different dating methods used on the same rock. For example, this is Sunset Crater National Monument. It is south and east of the Grand Canyon in Arizona. It's a relatively small volcano, beautiful though. It gets the name Sunset because the cinders at the top just glow at sunset. Now, anybody who knows anything about Arizona, New Mexico, that part of the United States would know that there's a large number of Indian ruins in this area. As a matter of fact, there are Indian ruins right in the park area. And so let's think. We know that this eruption can be dated at about 900 years ago. We can do that by tree ring countings because 900 is not a big deal. And we know that there were Native American Indians living in the area. First of all, there were remains of their houses and so forth are there. And also, in the cinder cones, in the lava flows from this eruption, we found Native Indian artifacts. So we know that there were people living there at the time that the eruption occurred, and some of their artifacts were trapped in the material from this eruption. So, there were Native Indian artifacts found in the lava flows and cinder cones. Now, this is volcanic rock. Now, when it comes to volcanic rock, the method of choice here would be the potassium-argon method of dating. And so we potassium-argon dated some of this material, and the laboratory that did the work came up with a date of 210 to 230,000 years old. I think that's more than 10%. Am I right here? Oh, Or what about this rock? This comes from Australia. This is a piece of volcanic rock from an eruption in Australia. Inside the rock, when we cut it open, we found this burned wood. It's really charcoal. So let's think. This volcano erupted. The rock completely surrounded a piece of wood. There's no question there's no contamination here. The rock completely sealed the wood inside. Now the heat of the lava caused the wood to burn. And so we were left with basically charcoal inside the rock and lava rock on the outside. Now, of course, since this is charcoal, you would use the carbon-14 dating technique. And the rock is volcanic, so you would use the potassium-argon technique. Now, understand, please, I don't agree with these dates. You do understand that. I believe the Earth and the universe are 6,000 years old. However, the laboratories that did the dates got for the carbon-14 date on this wood an age of 45,000 years old. Now again, I don't agree with it, but that's what they got. The lab that did the potassium argon date on the piece of lava got a date of 37 million. I think I see a problem here. I think that's more than 10%. Am I right here? Oh. Now, ladies and gentlemen, I'm particularly proud of this particular one, so I want you to take careful attention. Let's go back to your 1801, Hualili, Hawaii, on the big island of Hawaii. Now, you know the Hawaiian Islands are just volcanoes that stick out of the water, right? So I want you to think about this. So the volcanoes of the Hawaiian Islands are just coming up from the ocean floor, sticking out of the water here, 2.6 miles and higher here. But here are these volcanoes in the Hawaiian Islands. Now, in 1801, there was an eruption of one of these volcanoes, and the lava flowed from the top of the mountain, down the side of the mountain, into the ocean water, went all the way down the side of the volcano, all the way down to the ocean floor, 2.6 miles down, okay? Now, people were there to see this eruption occur in 1801. Now, I'm kind of proud of this, so I want you all to pay close attention to this, okay? Are you ready? Come on, are you ready? Okay. In 1801, there was an eruption. You missed it, didn't you? Come on, I'll show it to you one more time, okay? In 1801, there was an eruption. Now, you're all supposed to say, ooh. See, I'll show you one more time. See, in 1801, there was an eruption. Ooh. There you go. Well, we got the bright idea. Let's send a robot down and test this lava flow for the age using the potassium argon method. So we sent a robot down. It went down 0.8 of a mile, got a 0 million years old. Now, first of all, that is correct, because think with me for a second. It was only 200-year-old material. Potassium argon is not good on hundreds, thousands, hundreds of thousands. It's only good on millions. And so if this material is only 200 years old, then 0 million is correct. Everybody with me here? We got the bright idea, though. Let's take the robot, let's go down 2 miles, took a sample, got a potassium argon date of 12 million years. We said, well, that's interesting. Let's send the robot all the way down to the ocean floor, 2.6 miles down, took a sample, got a potassium argon date of 21 million. I think I see a problem here. How about you? These methods do not work. None of them work. They all start with 5 false assumptions or 7 false assumptions, and none of them work. Well, let's go on. This is my favorite kind of fossil. Now, my favorite kind of fossil is called a polystrate fossil. Now, again, when I use a big word, I always like to explain what it means. All of you would know the word poly means many, correct? Now, straight, strat, stratum, this all refers to layers. And so a polystrate fossil is any fossil which penetrates through 2 or more layers of the fossil record. Now, they are usually tree trunks, but they're often bone. But any fossil that penetrates through 2 or more layers of the fossil record, they are usually tree trunks, but they are often bone. Now, here you see in this photograph from Australia, many, many layers. Is that correct? Everybody see the polystrate tree trunk? Well, if you can't, it's right there. But what's particularly interesting about it is this. First of all, it's not petrified, it's coalified. This is a tree trunk turned to coal, but you'll notice it has no roots and no tops. It's just a log. Is that correct? Kind of tells you it didn't grow there, doesn't it? Well, let's think about this. How did coal form anyway? I mean, how many of you remember being taught in school the old swamp theory of coal formation? They used to teach us in school back, when I was in grade school, they used to say, oh, there were forests and swamps covering the earth 360 million, suppose, years ago at the time of the Carboniferous period, that these trees grew up in these swamps and they fell over and died, and they built up in the water of the swamp, and because there's so little oxygen in the swamp water, the trees piled up one on top of the other, and that's how we got coal. Does that sound at all familiar? But nobody teaches that anymore, at least not any honest evolutionist, because they all know it's not true. You see, first of all, let's take a little look. Here you see some small coal layers or coal seams, is that correct? But first of all, think with me. Do you notice it's flat on the bottom and flat on the top, is that correct? So first of all, does anybody here see roots coming down from below these layers? No roots. It's flat on the top, flat on the bottom. Number two, you only find natural gas, coal, and natural oil between layers of sedimentary rock. Now, what is sedimentary rock? That's layers of dried out mud, is that correct? So you only find natural gas, natural coal, natural oil between layers of dried out mud or some kind of sandstone. But there's something else here too. Notice right here. See how this coal seam forks right here? At the fork right there? Well, once they started realizing that, they started realizing the swamp theory simply wasn't true, and they stopped teaching it altogether. Now, this is a pure layer of anthracite coal. Now, anthracite coal is the hardest, densest, blackest, bestest coal there is. Anthracite coal is the really good stuff. Now, this comes from our state of Michigan. But this is about 1.5 foot to 2 foot thick layer of pure anthracite coal, the really good stuff. Now, let's think. To get anthracite coal, you have to have 10-foot thick layer of plant and wood deposits compressed down to 10 to 1. Okay, so it takes 10 feet of material compressed to 1 foot to get hard anthracite coal. Now, if you take 10 feet and you compress it maybe 3 to 1, you get soft coals like lignites, and 5 to 1, you'll get soft coal. Maybe down 5, 7 to 1, you'll get bituminous coals and so forth. But it takes 10 to 1 compression ratio to get anthracite coal. However, in our state of Utah, we have a pure layer of anthracite coal 200 foot thick. Now that tells you there had to be a layer of logs and vegetable material 2,000 foot thick there at some time in the past to be compressed down to 200. Is that correct? I would suggest to you only a worldwide flood could do that. A layer of logs and wood, 2,000 foot thick, all in one place, all at one time, would require a worldwide flood. And this is a bell found in 1944 in medium grade coal in our state of West Virginia, but the coal is supposedly 300 million years old. Oh, it's a very unique alloy and has a iron clapper on it and so forth, but this is a pre-flood bell used between creation 6,000 years ago and the flood of Noah by somebody, and trapped in the coal from the flood. And doesn't it take millions of years for fossils to form? I mean, I grew up on the campus at the University of California, Berkeley. Now, I did that because my father was a student at Berkeley. He got his degrees at Berkeley. He went on to become a professor at Berkeley, at one time a secretary to the president. And I actually grew up on the campus of the University of California, Berkeley. Now, that's the bad news. Here's the good news. The good news is that when I was not in the California public school system learning evolution in elementary school, well, I was in the paleontology laboratories at the University of California, Berkeley, learning about dinosaurs, fossils, and evolutionary theory from PhDs when I was just in elementary school. I learned about this so well that by the time I hit the 3rd and 4th grade, they used to borrow me from one class to the other, and I used to teach the other children about fossils, dinosaurs, and evolutionary theory because I knew more about it than the teachers did. That's an absolutely true story. Now, they taught me back in those days at Berkeley that it takes millions and millions of years to get fossils. They told me that dinosaurs, been dead for 65 to 70, up to 150 million supposed years. But I don't believe that anymore. I don't. Now, here's why. They say it takes millions and millions of years for a fossil to form. Is that correct? Right? Well, let me show you a fossil. This is kind of an interesting fossil. It's called a Teddybearosaurus. Now, this Teddybearosaurus fossilized, it only took 4 months. This was formed along the Thames River in England. There's a place where they have this overhang and a walkway underneath, and it's limestone rock, and there's water that comes over the limestone rock along the Thames River there, and people actually walk along underneath, and they tie tennis shoes and teddy bears and other things, Coca-Cola bottles, you know, on long strings, and they come back, and 4 months later they have a fossil. You're not impressed? Well, how about this fossil? This is a coil of man-made rope, but this fossilized in only 2 weeks. Are you impressed? Well, if you're not impressed yet, how about this? I think you'll agree, that is a fossilized fish, is that correct? But this fossil fish is quite interesting. You see, according to the evolutionists who found it, it died and was fossilized in less than 5 hours. Oh yeah. You see, this comes from Brazil. The Santana Formation was reported in 1989, but we found fossil fish with fossil gills, fossil muscles, fossil stomachs. The evolutionist paleontologist who found it did not allow his theory to get in the way of a good scientific observation. I applaud him for that. I really do. I really do. And he said this, quote, "What is clear is that the fossilization process took place moments after the fish died and was completed within only a few, probably less than 5 hours," unquote. But he went on to say this, in this case, quote, "Instantaneous fossilization," unquote, "is suspected to have been the very cause of death." Did you get that? DOA, fossil. This evolutionist paleontologist was making a valid scientific observation. I do applaud him for this. He was being honest. He didn't let his theory get in the way of his, observation. And he made a good scientific observation. What he said was, based upon what he found, the cause of death might well have been fossilization. So I guess it doesn't take millions of years to get a fossil, is that right? Oh. And then we have helium missing from the Earth's atmosphere. Helium is made in the crust of the Earth by the decay of radioactive material. It's the only way helium is basically made on Earth. Now, let's think about this. It's produced by the decay of radioactive materials like uranium in the crust of the Earth. Now, when that helium is made in the crust of the Earth by the decay of radioactive materials, it leaks out through the rock because it's an inert gas. It won't combine with anything else. It leaks out of the rock and into the atmosphere. Now, it is not lost into outer space. As a matter of fact, we actually get a slight addition of helium to the Earth's atmosphere by cosmic winds, but it's not lost into space. So whatever helium has been made on Earth is still basically here. The problem is this. Though it escapes in the atmosphere and stays here, there's only enough for the atmosphere to be less than 2 million years old. Now I would find it problematic to have an Earth that was 4.6 billion years old, but an atmosphere that was less than 2 million. How about you? And here, there's too much salt in the Dead Sea. Now here's a satellite photograph of Israel. Here's the Sea of Galilee, the Jordan River, the Dead Sea here. But the Dead Sea has too much salt in it for it to be old. The north end today is 31% salt, the south end 37% salt. This is why you can't drown in it unless you strap on about 500 pounds of lead weights. But think with me for just a moment. All this salt would actually accumulate in less than 13,000 years. But evolutionists will tell you that the Jordan River Valley, this volcanic rift valley that we have here, they will say it is anything from 5 to 10 up to 20 million years old. But think with me for just a second. If in fact the Dead Sea were, and the Jordan River Valley were 5, 10, 20 million years old, well, that means that the Jordan River flowing into the Dead Sea would have to be cleaner than distilled water for 20 million years. Anybody here ever seen the Jordan River? It's not that clean, right? So this is what we call a regional geochronometer, but it simply shows that this is not 5, 10, 20 million years old. It's less than 13,000 and totally acceptable with only 6,000, or in fact 4,500, which is from the time of Noah's flood. I'm sure you've also all noticed that the moon is moving away, right? You all had noticed the moon is moving away, right? Where are your powers of observation, people? The moon is moving away from the Earth at a staggeringly fast rate. Come on, are you all ready to be staggered? Come on, are you all ready to be staggered? Well, the moon is moving away at a staggeringly fast rate. It's moving away at 2 inches a year. Come on, 2 inches a year. Aren't you staggered? You're not? Well, you should be. Think with me for just a second. Today, you don't have to believe me. Today, you can prove this in a laptop computer, desktop computer at home or the office. The moon is moving away at 2 inches per year. Now, do any of you remember something called the law of gravity? Come on, you all do remember something called the law of gravity, right? And the law of gravity says basically that as two objects get closer together, there's a stronger and stronger pull together. Is that right? Now, it's an inverse square law. You half the distance, you quadruple the force, and so forth. But you plug the formula into a laptop computer today, and you can prove to yourself, think with me, if the moon is moving away at 2 inches per year now, well, if I go back 1 year, it would be 2 inches closer, correct? Another year would be 2 inches closer. But as the moon starts to come back towards the Earth, well, then the force of gravity starts to increase. Is that correct? And the rate at which the moon comes back gets faster and faster, correct? Now, again, as I said, you can prove this in a laptop computer. If you go back in time, the moon would come back in, spiral in, and hit the Earth 1.4 billion years ago. Now, evolutionists say that the Earth and the moon are the same age. They say they're 4.5 to 5 billion supposed years old. Most of them say 4.6 billion. But if evolutionists were telling the truth, then that would mean that the moon was attached to the Earth for the first 3.6 billion years. Is that correct? And then it has been moving away ever since. Have I got that right? Hello? Now, there's something else I want you to notice here. Did you notice the bouncing arrow? And did you notice down here, I'm going from the age of the Earth at 4.6 billion, and it's getting younger. So did everybody see that now? I want you to, okay, right, here's the bouncing arrow. And then the age of the Earth gets younger. See how, was that cool? Oh, come on, that was neat, right? Thank you. We want to keep watching these bouncing arrows. You also want to keep, watching the bouncing arrows and the age of the Earth getting younger down here, okay? Just kind of keep that in mind as you're watching the slides. Well, let's think about this too. If the moon comes back towards the Earth and the force of gravity gets ever larger, well, what's it going to do? Well, what is the major physical impact of the moon upon the Earth? It is tides, correct? Now, if the moon starts to come back towards the Earth, well, let's think about this. If the moon comes back towards the Earth, the tides would get higher and higher, correct? Right? Now, if you go back 1/2 billion years, and again, just on a laptop computer, well, the tides on Earth would rise 1 mile high twice a day. I think my first question would be, do you know how to breathe underwater? And keep in mind, if the tides rise 1 mile twice a day, just in your mind start thinking about erosion for just a minute, okay? Now, another argument that evolutionists use, supposing that the universe is, well, millions and billions of years old, they say it takes millions and billions of years for light to travel here from distant stars, distant galaxies. Is that correct? Now, I'd like to ask everybody a question. How many of you were taught, as I was, the speed of light is a constant? Come on, in school they taught us the speed of light is a constant, right? 186,000 miles a second, 300,000 kilometers a second. Is that correct? But how many of you know that's not true? The speed of light is not a constant. As a matter of fact, if you're looking for this material, I have it on my website in a free article you can just download. And I'm citing mostly evolutionary scientists. But the fact of the matter is, the speed of light is not a constant. You see, these are just some of the citations of work done in the last few years. But we've actually been able to measure the speed of light slowing down since 1675, when Romer made the first measurements of the speed of light in an accurate way. But research done in the last 10 years has been able to actually accelerate light, decelerate light, and even stop it and start it again. Now, if you can speed it up, slow it down, stop it, and start it again, would you agree with me it's not a constant? Is that right? Oh. Now, I will point out too here, the creation astronomer, Dr. Barry Sutterfield of Australia, using one method of scientific approach in astronomy, and Dr. Trotsky, who is from Nizhny Novgorod, Russia, which is my sort of headquarters in Russia. I always go to Russia twice a year. I've been there 28 times and so forth. But he is an atheist, but he's an astronomer working in Russia in Nizhny Novgorod, and Dr. Sutterfield working in Australia, one a creationist, one an evolutionist, and using two totally different methods of scientific proof, have come to the same conclusion. Both of them conclude that at one time recently, the speed of light may well have been 10 million times faster than today. Now, if the speed of light were 10 million times faster than today at some time in the recent past, I think that would drastically change your idea of how long it takes light to get here from distant objects. Is that correct? I think so too. And I'm sure you've all noticed that the galaxies are rotating too fast. Is that right? Come on, you had noticed, right? You hadn't noticed? Where are your powers of observation, people? Yeah. Now, not all galaxies rotate, but there are two kinds of galaxies specifically that do rotate. And when we take a look at these rotating galaxies, it doesn't matter how far across the universe we see, they're rotating too fast. Evolutionists call this the winding up dilemma. They've known about it for over 60 years. But it doesn't matter how far away we look in the universe, we see distinct spiral galaxies at great distances in every direction. Now, I want you to think about this for a second. When we see these spiral galaxies, we see clear spirals, we see individual stars at great distances, but these galaxies are rotating. Now, we can measure how fast they rotate. Now, if you think about it, if some of these galaxies were as old as evolutionists claim, they would be 100 to 200 turns since they were created or came into existence. But if they had turned 100 to 200 times, when we take a picture of them, they should just look like a smear on the photographic plate. But instead, we see them as distinct spirals with just 1, 2 turns perhaps at great distances. This tells you they haven't been rotating all that long. As a matter of fact, it limits the age of these galaxies to, at most, well, a few 100 million years old. Now, if the universe is less than a few 100 million years old, then the Earth must be less than a few 100 million years old. Is that correct? You all are watching the bouncing arrows, right? Okay, I'll do that one more time now. Okay, see? There's the bouncing arrow, and the age of the Earth gets younger, right? Well, let's continue. There's too much salt in the seas. I mentioned there's too much salt in the Dead Sea, but there's too much salt in the regular seas as well. Today, the oceans are approximately 3.5% salt content. Now, the total amount of salt in the oceans today would accumulate, at current rates of accumulation, between 42 and 62 million years. That makes the Earth's oceans less than 62 million years old, which of course would make the Earth younger. Is that right? And this is the Cape Hatteras Lighthouse, made famous in the United States. It's in North Carolina. It was built in 1870, one of the most historic lighthouses in the United States. When it was built in 1870, it was 1,500 feet from the water. Okay, so it was 1,500 feet from the ocean in 1870. In 1989, 116 years later, it was 160 feet from the ocean. I don't think the lighthouse moved. Well, actually it did. You see, in 1999, we moved it back 2,950 feet from the water to try to preserve it as a historic lighthouse. But even now, we think it may only preserve it for another 100 years. And let's think about this erosion problem. These are the White Cliffs of Dover, made famous in song and history. Now, evolutionists say that the White Cliffs of Dover are Cretaceous deposits made 65 million supposed years ago. Now, the White Cliffs of Dover are basically trillions of single-celled creatures called diatoms that are fossilized. It's actually what you make toothpaste out of. It is. That's the abrasive in toothpaste. Now, let's think about this. According to evolutionists, the White Cliffs of Dover are 65 million years old, correct? I don't think so. Think with me for just a moment. The continents are all eroding too fast for the Earth to be old. The cliffs of Dover, if they were eroding away at only a ½ foot per year for 65 million years, well, that would be about 6,200 miles of coastline that would have to have been eroded westward through England, that's greater than the distance between, say, Tokyo and London. If you hadn't noticed, England's not that wide. And these are 5 photographs taken from 1986 to 2002 at Happisburgh, England. You can clearly see in this photography right here the erosion of the coast in only 16 years. Is that correct? And you can actually see it happen before your eyes. Is that right? As a matter of fact, think with me for a moment. Since the Roman times, 2,000 years ago, the English North Sea coast has eroded 2 miles west along the east coast of England. We know of 35 villages in the Roman census 2,000 years ago that have been completely lost into the sea. That's an average of 5 foot per year. Clearly that erosion rate, cannot have been going on for millions and millions of years. Is that right? There simply wouldn't be in England. And let's face it, if you erode off the land, you've got to erode into the oceans. Is that correct? I mean, you erode the mud off the land, it goes in the ocean. But there's not enough mud in the oceans. You see, when we take a look at the ocean floor, we have recently discovered a spot in the Pacific where there is no mud. It's exposed bedrock. But even being super generous, trying to find the greatest, thickest layer of mud anywhere on the ocean floor today, all of the mud would still accumulate in less than 12 million years. So that would make the Earth young. Is that right? And then, of course, this is the beautiful Cat's Eye Nebula. Now, a nebula is an exploded dead star. Now, some of them are beautiful, some of them are just downright ugly. But a nebula is an exploded dead star. Now, listen to me very, very carefully. In spite of anything you've seen on TV, radio, magazines, movies, or whatever, we have never, ever seen a star born. Did you hear me? We have never, ever seen a star born. If evolutionists were correct, then suppose it would take millions and millions of years for stars to be born. Now, have we been around that long? So we've never, ever seen a star born. You understand me? Another thing, too, think with me for just a moment. Now, I'll try to say this in the most diplomatic way I can think of, and I hope you'll agree it was. Tell me something. If you took one photograph of a human baby being born, okay, so if you take one photograph of a human baby being born, and the photograph was taken in the middle of the birth canal, could you tell whether the baby was coming or going? No. Not based on one photograph, is that right? We have never, ever seen a star born. But we have seen stars die, and when they die, they explode, and they push out gas in millions and millions of miles, and what's left of the star illuminates behind the gas so we can see the gas. It's, as I say, some are absolutely beautiful, some are just downright ugly. Now, here's the thing. There are too few supergalaxies in our galaxy, or in the universe, for that matter, for it to be old. Now, we can count them. One star dies about every 25 years per galaxy. So approximately one star dies per 25 years per galaxy. Now, evolutionists claim that the Milky Way galaxy, that's our galaxy, is 10 million years old. Here's the problem. We can only find 200 dead stars in the Milky Way galaxy. This indicates the age of our galaxy is less than 7,000 years old, or perfectly consistent with 6,000. But if evolutionists were telling the truth, there should be 400,000 dead stars in our galaxy, but there's only 200. And understand that we can see in other nearby galaxies like Andromeda, we can also see stars exploding and dying. And they occur 1 per 25 years per galaxy, but they're missing. It proves the whole thing is young. And I'm sure you've also noticed that the sun is rotating too fast, right? Come on, you've all noticed the sun is rotating too fast, right? Please do me a favor, don't go out and stare at it. But I want you to think about this. As the Earth and Moon are rotating, so is the sun. The sun is a huge ball of gas. It's 860,000 miles across. It's basically 430,000 miles in radius. It's a huge ball of gas, and it is rotating. Now, it is incorrect to believe that the sun is a huge fusion furnace that it's all burning up. That is not true. It isn't burning up. But there is a small fusion furnace in the center of the sun, which is, so to speak, burning up. Now that fusion furnace in the center is producing particles which are trying to get out of the sun. So let's think about this. Particles are leaving the center of the sun, but as they're trying to get out, they get in the way of the particles coming around. Okay, so the particles are trying to come out, but they get in the way, hinder the particles rotating around, just as the tides on Earth slow the rotation of the Earth. So the tides slow the Earth. Here, in this case, the particles coming out slow the rotation of the outer layers of the sun. This would eventually stop the outer rotation of the sun, but the sun is still rotating. And since the sun is still rotating, we know it has been rotating for a very short time. As a matter of fact, it's only been rotating for less than 1 million years. Now, if the sun has been rotating for less than 1 million years, that would make the Earth young. And there's too much dust in near space. It doesn't matter where we look in the solar system, between the planets, the moons, and so forth, there's too much dust. You see, 98% of the mass of the solar system is in the sun. It has tremendous gravitational force, but so do the planets and the moons. But there's too much dust, because if the solar system were millions and millions of years old, gravity of the sun and the planets, well, this gravity of the sun and the planets would all pull that dust in. It would sort of vacuum the solar system, and there wouldn't be any dust, but the amount of dust that we now know to exist limits the solar system to only a few thousand years old. Well, I think you'll admit that would make the Earth young. Is that correct? And then, of course, there's the decay of the Earth's magnetic field. In my personal opinion, the decay of the Earth's magnetic field is one of the single strongest arguments for a young Earth. As a matter of fact, it's irrefutable. There has never been a totally adequate explanation by evolutionists for this. We've been able to measure the decay of the Earth's magnetic field since the early 1800s. But it decays in the same way that a radioactive material decays. It has a half-life. That half-life is 1,400 years. So every 1,400 years, 1/2 of the strength of the magnetic field decays. Now, if you go back in time, it would double, right? So let's think about something. The Earth's magnetic field is tremendously important because the magnetic field of the Earth protects us from the deadly radiation that comes from the sun. The cosmic winds, the deadly radiation that comes from the sun is ionized. It comes and hits the Earth's magnetic field. The Earth's magnetic field bends it and comes in at the North Pole and the South Pole. It causes what's called the northern lights, the southern lights, the aurora borealis, the aurora australis. But this is deadly radiation streaming into the Earth's. Now, if we didn't have the Earth's magnetic field, that deadly radiation would come straight in and kill everything on the Earth. So the magnetic field of the Earth is tremendously important to us even being alive today. Now, it will be gone in about 2,000 years. This is one reason why I know scientifically that the Lord Jesus is coming back sometime fairly soon. Because I've read the book and there's going to be people here to meet him. And because of the decay of the Earth's magnetic field, the Earth isn't going to last for a whole lot longer. But if I go back in time and double the strength of the magnetic field every 1,400 years, well, 10,000 years ago, the strength of the field would kill all life on Earth. So if you go back to what would be 8,000 BC, the Earth's magnetic field would be so strong it would kill all life on Earth. Without it, the sun would kill all life on Earth, and it'll be gone in about 2,000 years. We live in a very narrow band of time. Think with me. Based on the strength of the Earth's magnetic field, all life would be dead 10,000 years ago. So if no life, no living organism could possibly exist on Earth even 10,000 years ago, if there had been a 10,000 years ago, then is it possible for evolution to have been occurring on the Earth for the last 1.5 to 4 billion supposed years? Well, no. Is that right? And it's not going to last a whole lot longer. I would like to make this statement to you. God never intended the Earth to last for a long time once it became, well, imperfect. It became imperfect because of human sin. Did you hear that? So God never intended the Earth to last for a long time once it became imperfect. Well, this limits the age of the Earth to less than 10,000 years and, of course, makes the Earth young. And then, of course, we have what are called short period comets. Now, I'm sure many of you have seen comets in your lifetime. And comets are basically big, dirty ice balls. They're just big, dirty ice balls. They're just rock and ice. We've taken close-up pictures. We've sampled them and so forth. Now, comets go around the sun. They get very close to the sun. When they get close to the sun, they melt. So they lose about 3 to 5% of their mass every time they go by. So let's think about this. We have these comets that are called short period comets. Now, almost all comets are short period comets. There are a few long period comets. Now, short period comet means it has an orbit of 200 years or less. Now, let's think about this. We still have short period comets in the solar system. They would all be gone in less than 10,000 years. So the fact that we still have short period comets says that the solar system is less than 10,000 years old. Even the long period comets would be gone within 100,000 years. Well, that makes the solar system and the Earth young. And then, of course, there's too much uranium in the oceans. You see, uranium is a salt in nature. It dissolves in water and will go into the oceans. But there's too much uranium in the Earth's oceans for the Earth's oceans to be billions of years old. As a matter of fact, it limits the age of the oceans to less than 10,000 years old. Well, that would make the Earth young. And then, of course, high-pressure natural gas and natural oil wells still exist on Earth. Not too long ago, I was in our state of Arkansas. There were hundreds and hundreds of natural gas wells. And in our state of Arkansas, they were still finding natural gas at pressures of 9,000 pounds per square inch. But around the world, we still find natural gas wells up to 20,000 pounds per square inch. Now think with me. You only find natural gas, natural oil, and natural coal between layers of dried out mud or some kind of sandstone. Now, sandstone has porosity. I mean, when you go down to the beach and you see the wave come in and hit the beach, well, the wave comes back into the water, but you'll see the water go down in between the sand grains, correct? So sandstone has porosity, and gas can leak through a rock. You can actually push a gas through a rock if the rock is sedimentary. You give me any natural gas that occurs on Earth, any natural piece of sedimentary rock, give me any pressure you want to start at, I will take it into a laboratory and I will tell you how long it takes to push a gas through a rock. Because you can push it through a rock if it's sedimentary. Well, the problem is this. No natural gas or oil well we have ever found could be more than 100,000 years old, or the pressure would already have been released into the atmosphere, and that, of course, would make the Earth young. I've noticed these arrows are all stacking up on the right side. How about you? And there's not enough Stone Age skeletons. Now, if a skeleton is buried in the ground, well, if it doesn't become fossilized, it will still decompose. The molecular bonds will break down, and over time, the bone will actually turn to dust if it's not fossilized. Now, here's the problem about Stone Age skeletons. Skeletons are said to last perhaps 200, 250,000 years before they're just dust in the ground. Assuming a Stone Age population of 1 to 10 million at any one time, and let's say the Stone Age supposedly produced people was 185,000 years, well, that would mean you'd have 8 billion burials. Please tell me, where is the evidence? Where are the artifacts? Where are the skeletons? We only find a few thousand skeletons in the ground. This actually proves that the Earth is young, limits the Stone Age to a few hundred years. Well, that sounds biblical. What is the quote, Stone Age, unquote? Well, let me ask you the first question. Has there ever been a time on Earth when there was not a Stone Age? Did you hear that question? Has there ever been a time on Earth when people didn't use stone tools? No, there's never been a time on Earth when people didn't use stone. We still use stone tools today. Has there ever been a time on Earth when there wasn't an Iron Age or a Copper Age? Well, think about it. According to the Bible, Tubal Cain, 3 generations from Adam, was smelting ores before the flood. Is that correct? And I just showed you pre-flood Bel. Is that correct? Well, the fact of the matter is what they say, the Stone Age? The Stone Age is nothing but the people living in the area of the Middle East, leaving at the time of the Tower of Babel experience and migrating to Europe, living in caves for a couple of hundred years, which was a smart thing to do in Europe, because I think you'll agree, you think of Neanderthals, Cro-Magnons, and so forth. They're living in caves in Europe. Now, that's a smart thing to do in Europe because, they're cool in the summer, they're, warm in the winter, and they're incredibly cheap to build. And, of course, today you can study Neanderthal culture. They had language, art, music. They were religious. They buried their dead with religious artifacts and graves and so forth. They were absolutely, totally, 100% human. Even the DNA proves that they're human. So, the Stone Age is just nothing but the people who left the Tower of Babel and migrated to Europe and lived there for a couple hundred years, establishing civilization. And dinosaurs lived recently. You know, when I was growing up at Berkeley, they told me dinosaurs haven't existed 65, 70 million years. They all became extinct. That a human being never saw a dinosaur. When I was an evolutionist, I believed that. I don't anymore. You see, when you go to these natural history museums, they show you all these fossils of dinosaurs and dioramas and so forth. They tell you, oh, you know, they've been dead for 65, 70 million years. I don't think so anymore. For example, how many of you know, 1990, we found dinosaur blood cells in a T-Rex bone, and the hemoglobin was still in the blood cells. You don't believe me? This is an actual photograph of dinosaur blood cells in a T-Rex bone found in 1990 in Montana by the evolutionist paleontologist Dr. Mary Schweitzer. Now, Dr. Mary Schweitzer is an incredibly intelligent woman, unfortunately still an evolutionist, but she's a very talented paleontologist, a very intelligent woman. And in 1990, now she's a bone digger. She likes to dig bones, and she really likes to dig up T-Rex bones, and you only dig up T-Rex bones in Montana. So she's working at Montana State University Northern Campus in 1990. She's out digging up T-Rex bones, and she finds blood cells inside. Well, obviously, this discovery refuted evolution. Is that correct? I mean, I don't know about a problem that I have. I have a big problem with blood cells lasting 65, 68 million years in the ground. How about you? You know? Well, when she found this contradiction to evolution, the university wanted to reward her, so they fired her. But being a very resourceful, very intelligent woman, she got a job at a actually better university. It was kind of like being kicked upstairs. She got a job with North Carolina State University. In March of 2005, she's back in Montana digging up T-Rex bones, because that's what she really likes to do, and she found this, dinosaur flesh. This is real, fresh dinosaur flesh. It was soft, moist, resilient. You could squeeze the blood out of it. This little ligament right here was still elastic. You could pull it apart and it would snap back together. This is a blood vessel. These are blood cells. She is asking this question. How could these cells last for 65 million years? I think she's asking the wrong question. I think the question she should be asking is, are they 65 million years old? And in Spain, reported by the National Geographic magazine, well, this is 2006, we found supposedly 10-million-year-old frog and salamander fossils, but inside we found fresh bone marrow. Again, I have a problem believing that bone marrow could live and, exist in the ground for 10 million years, And we have found what are called living index or key fossils. Now, let me explain something, folks. I said earlier, evolutionists do not use radiometric dating processes to date anything because they all have 5 false assumptions, 7 false assumptions, and none of them work, correct? So how do evolutionists date these layers that are in the ground? They don't use these modern scientific techniques because they don't work. This is actually how they do it. They tell us how old the rock layer is by the fossil you find in it. Then they tell you how old the fossil is by the rock layer you found it in. Should I repeat myself? They tell us how old the rock is by the fossil you find in it. Then they tell you how old the fossil is by the rock you found it in. Everybody with me? Yeah. And these fossils are called key or index fossils. Now, the problem is we find them alive today. For example, the coelacanth fish, the lobed-fin fish that's so ugly only a mother would love it, supposedly extinct for 70 million years. 100 million supposed years ago, this is the fish that supposedly evolved into the amphibians and then became extinct itself 70 million years ago, after it evolved into the amphibians. Or the Neopalina, a mollusk supposedly extinct for 280 million years. Or the Lingula, a brachiopod supposedly extinct for 400 million years. Or the taro branch, supposedly extinct for 300 million years, have all been found alive recently. The coelacanth was found alive in December of 1938 in the Comoros Islands, north of Madagascar, east of Africa. But they were found alive in December of 1938. They have never changed. They look exactly like fossils that are supposed to be over 300 million years old. They've never changed, and they're still alive. Now, if they're alive and they've never changed, is it possible that they could have evolved into the amphibians? Well, that's a stretch. And exactly 60 years later, in 1998, we found another population of coelacanths alive off the coast of Indonesia, 5,000 miles away from the first population. Evolutionists are starting to say, well, you know, they're not extinct, and maybe they're a lot more common than we thought they used to be, you know. Well, all of these have been found alive recently. Now let's think about this and kind of wrapping things up. We have evidence that the Earth and the universe cannot be old. It doesn't matter whether you look in the Earth, on the Earth. We have more than enough evidence to convict. It doesn't matter whether you look near the Earth, in the solar system, in the galaxy, across the universe. We have more than enough evidence to prove it is all young, perfectly consistent with 6,000 years of age. Now, let's be good scientists. Let's take a look at the sheer weight of evidence. Now, evolutionists have 5 major arguments in which they suggest it may be billions of years old, but there's not 1 ounce of proof that it is old. Do you understand me? Evolutionists have not 1 proof that is undeniable that it is old. They only have 5 major arguments to suggest it might be old. We have over 200 arguments to suggest and prove it is young. Okay, so they have 5 arguments that suggest it might be old. We have over 200 arguments that prove it's young. Now let's just be good scientists. Now they have only 5 major arguments that, well, suggest it might be old. We have over 200 proofs that it is young. Now just being a good scientist, sheer weight of evidence, which one of those 2 would you go with? Well, I think young is the only reasonable scientific answer. Is that correct? Now, Sir Charles Lyell, the evolutionist who was the mentor of Charles Darwin, wrote a set of 4 books starting in 1830 to 1837 called Principles of Geology, volumes 1, 2, 3, 4. And these are the basic books that are the foundation of all evolutionary geology today. He is the man most responsible for the expression, the present is the key of the past. Now, evolutionists believe in what is called uniformitarianism. Uniformitarianism means this: it's the belief, the faith belief, that all the natural laws, all the natural principles, everything has acted uniformly in exactly the same way for an eternity past. So an evolutionist believes in uniformitarianism. It is the belief that all the natural laws, all the natural processes have acted uniformly throughout an eternal past, and that only random chance working through eternal mass, energy, and time have produced all the complexity we see in the universe today. Now here's my last comment to you folks. If Charles Lyell, this great evolutionist, is correct, if the present is the key to the past, then it all has to be young and cannot be old.